So now we have the other version of rational equations that we could see, and quite frankly, this is the more user-friendly version. When we have a ratio said equal to a ratio, these are said to be in proportion to each other. So when we have a proportion, no matter what it looks like, my inclination is to cross-multiply. The only thing about this one is when I cross multiply, I really want to write what I'm doing first, then I'm going to do the actual multiplication. So I'm going to say 4 times x plus 5 is equal to x plus 1 times x minus 1. And then I'm going to start doing the distribution. The reason behind this is I don't want to make any sort of silly sign errors this early in this problem because everything after that will be incorrect. And I don't want to damage my precious ego. So 4 times x is 4x, plus 4 times 5 is 20, equals, and when we FOIL this out, we're going to get x squared plus x minus 1. And these x's are going to cancel each other out. At this point, we have a quadratic. If I did not have a quadratic, if this is just a linear situation, I would isolate my variable, be done, check my solution in the denominators to make sure it doesn't make them go to 0. But in this particular instance, I have a quadratic, so what I'm going to do is I'm going to do my best to decide which side to put all this information on. And there really isn't a wrong answer at this point, but there is a best sort of case, in my opinion. I would like to keep this 1, that coefficient of the quadratic term, positive. So I'm going to choose to subtract 4x from both sides, and I'm going to subtract 20 from both sides. And so I put the 4x underneath the other x terms that had actually canceled out. And I'm going to end up with 0 equals x squared minus 4x minus 20. All right, and now what I'm doing is I'm looking for factors of 20. Minus 21. Got to watch me on the simple arithmetic. I'm looking for factors of 21 that have a difference of -4. Pretty straightforward. I know what you're thinking. Of course, Don, that's pretty easy. You have 3 and 7. And if the 4 is negative, then that means our bigger term here is negative, and the 3 is positive. So that gives us an x squared plus 3x minus 7x, which gives us a -4x minus 21. But again, right here, I'm checking this. I have a positive 3x and a -7x, which gives us a -4x. So I'm going to take my two terms here. I'm going to set those two equal to 0. Again, as I said in the other video, if one binomial times another binomial is equal to 0, then one or both of these binomials must solve or equal 0 in and of itself. So x plus 3 equals 0, and x minus 7 equals 0, leaving me with x equals -3 and positive 7. Now I just need to check these two solutions in my original equation and make sure that it doesn't create either of these denominators to go to 0. And looking up here, it's almost as easy just to say, well, what two numbers would make it go to 0? -1 would make this side go to 0. -5 would make this side go to 0. Neither of these are those numbers. So there's our solution. X equals -3 and x equals 7. So there you have it. Between this video and solving rational equations, although I titled it expressions, solving rational equations number 1 and number 2 give you both the scenarios that you're going to bump into. Hopefully that helps.